Hi friends, in this session we are going to see two important aspects of data types in a C program. The first one is size of function. The size of function returns how many bytes allocated to a variable of any data type. So let us see that first, then we'll go to the second important aspect. So here I am declaring an integer variable called I, and let me directly print the size of it. %ld size of int is here size of, here I can give the variable name or the type, like I can also give int here, so I don't even have to declare it, but in general we declare a variable, right? So we can see that. Let me execute and see. So here we can see size of int is 4, means 4 bytes allocated, not bits. 4 bytes means 32 bits will be allocated. Let us also check size of other data types. So here we can see size of char is 1, size of short is 2, int we have already seen, which is 4, long is 8, float 4, double 8, and long double is 16. 16 bytes allocated for long double. So we can see the size like this. And let us also see an array. For example, I am declaring an array called integer array. I am initializing with some values. So I gave 9 values to an integer array. So let us see the size of this array. We already know the size of int is 4 bytes. That means for each integer it allocates 4 bytes. But here we are allocating 9 integers, right? Array of, here we can give 9, otherwise also it will take 9 because 9 values are there. So 9 4 ja 36 it should print. So let us see how much it will print. Here I am saying array name here. So let us see what it will print. Here size of int array is 36. So 4 bytes for each integer. So 9 4 ja 36 bytes allocated to this array. Suppose if you want to see the length of this array, let us for example, so let me copy this, length of array. That means how many integers were allocated, dividing size of array by size of int, right? So it should return 9. We can see size of int array is 36, length of int array is 9. That means 9 values allocated to this array. So we can check the length of the array during runtime also dynamically. So let us move on to the other important aspects of the data type. So we also want to know, here we have seen, for example, long double allocates 16 bytes, right? So what is the maximum value it can accommodate in long double, and what is the maximum value a short can accommodate? What is the maximum value an int can accommodate or a char can accommodate? So we can see that. So that is called limits. So minimum value and maximum value, that is called limits. For that we need to include limits.h. And here in this limits.h library, constants are defined. We can even open this limits.h file and see what are all the constant limits defined in that file. In your installation directory you can go and see that. But let us see what are the minimum value of char is %ld char min. Let us also see maximum value of char max. So here I am printing minimum value of char and maximum value of char. In a char type, what is the minimum value that can be assigned and what is the maximum value that can be assigned? So let us execute and see. See, here we can see minimum value of char is -128 and maximum value of char is 128. Of course, this is the ASCII value, but the char data type will store a character. For example, we have already seen in the previous programs, 65 is the ASCII value for capital A. So like that. So minimum is 128 and maximum 127. Similarly, we can see so the max size of unsigned character. Unsigned means only will have the positive values. So here there is no minimum, because anyway unsigned means it starts from 0, right? So let us see what is the maximum that can be stored in a unsigned char. So maximum value of char is 255, because earlier we have seen char max is 127 or something, but here char, unsigned char, can store more because it need not store the negative numbers. That explanation I have given in the previous data type videos. So similarly we can see unchar integer or any data type, just prefix with u. Let us see the difference for unsigned and signed. Here I am giving signed one, this is signed int, and this one is unsigned int. So here we can see the maximum value of signed int is this much, unsigned max is higher than signed max because it need not store the negative numbers. The first bit in case of signed integers is used for storing the sign plus or minus sign, but here first bit also will be used for the data. So out of 4 bytes, right, 36 bits, all 36 bits will be used to store data. Here 35 bits will be used to store data. First bit will be used to store the sign plus or minus sign. So this way you can check the limits of each data type using int min, like a data type underscore min, data type underscore max. Similarly u data type underscore max. This will be very useful in dynamic programming, so where you want to know the maximum value you can store at runtime. Thank you, and if you are new to this channel, please subscribe and press bell icon so that you will get notifications. Also please like the video and share it with your friends. Thank you.